Okay, so camera's on. All right. So a little bit of bookkeeping at the top here. Okay, check Canvas modules. For notes and videos. Okay, so if you go to the Canvas page right now, I think it takes you to the syllabus. Maybe once we've got that information down, I'll put the modules page as the home page. Okay, so I've got some scanned notes and some videos there for the various sections, as well as what homework problems are assigned for those sections. Okay, so if you haven't checked that, make sure you do that. Okay, who's got their grid? That grid that we had for the class, it had like the various days and what was happening on those days. Anything happening on Friday? And right, quiz 2, okay, quiz 2 on Friday. What do you think is going to be on quiz 2? Let's brainstorm.
Addition.
Okay, right, the addition stuff. Oh, one thing to point out, how about those homework questions? Rats! Rats! How about those quiz questions? How did I come up with those? I kind of gave away the answer.
They came off our homework.
Right. The quiz questions are selected from the homework questions, okay? So, you guys that took the quiz on Friday, I actually scanned those pictures from the book for the Egyptian numbers and other things like that, okay? I switched it up a little bit for you guys, but they were the decimal numbers that they asked you to convert to Egyptian, okay? So, one important reason to keep up with the homework. You'll do well on the quizzes, okay? If you run into something on the homework that gives you trouble, ask about it. Ask in class. Ask at office hours. Okay, last Friday and today I was a little bit busier in the morning than I normally am because I was doing some substitute teaching for somebody who was out. But I won't typically be doing that. So hit me up before class. I have office hours 9 o'clock, Monday, Wednesday, Friday. Hit me up on Thursday. I don't have classes on Thursday. Office hours 10 to noon and 2 to 3. Okay? So plenty of office hours to clear up questions on the homework. If you have trouble with a homework question, assume that will be on the quiz. Okay, don't wait till after the quiz to ask about it. I guess that's better than not asking at all, but best would be to figure it out before we have a quiz on that material. Okay, so homework questions are the quiz questions. When's the first test coming up? It's a ways away, but it's going to come fast.
February 5th.
Right, February something or other, 15th I think she said. Is that right? Or the 5th, right? Okay, February 5th. And look at what we have there. We got chapter 1, we're going to finish that. Then we're going to hit chapter 2. Then we're going to have a test over chapter 1 and chapter 2 together. Okay? The test questions are probably going to come from the quiz questions. There may be additional stuff on there, okay? But if I think a question is important enough to ask about it on the quiz, it may show up again on the test. Okay, so, quiz 2 Friday, when I start handing stuff back, start handing papers back, I'm going to ask that you keep those graded papers. Okay, 2 reasons. One of them was what I just mentioned. I mentioned that the test questions are likely going to come from the quiz questions. Okay, so you keep your quiz papers to study the questions I think that are important that are probably going to show up on the test. Okay, reason number 2, it's like a receipt. Okay? Once we get into the middle semester, I'm going to be doing a lot of grading. Okay? I try to do it pretty efficiently. I try not to make any mistakes. Sometimes I do. Sometimes you got a 20, I put in 10 on Canvas. okay? If you have the paper and you say, Dr. Mack, on Canvas I see quiz 3, I got a 20, but you put in a 10. If you show me the paper, easy, I'll fix it right here in class. If you can't show me the paper, well, SOL, right? So, keep those papers. All right, so let's go on to the next section of elementary math for teachers. Okay, so actually remind me of what we talked about last time. It was addition, right? And what did we do with it? We talked about a couple things.
Making multiples of 10.
Okay, so we talked about some mental math stuff where you want to make tens. Okay, so we're going to talk about that a little bit again today with subtraction. Okay, what else did we talk about with addition? So we had mental math. What else?
Any order property.
Okay, right, the any order property, which is kind of where the mental math comes from. Okay, we can look at the whole list. If there's two numbers that make a 10, we should add those together first and then do the next one. Okay, so any order property helps us with mental math. Like, how would we present addition to students that hadn't seen it before? What would we use?
Set model.
Right, maybe the set model. We have the set model, so you have a set that represents one number, a set that represents the other number, and a new set that represents the combined number. Okay, so that's great. There was a little bit of a weakness with that, because sometimes the students just count. They don't really add. So we can start out with the set model. Just because a model has some weaknesses doesn't mean we don't use it, okay? Everything has some strengths and weaknesses. Set model, very concrete, very easy to understand. The weakness is that students tend to just count the individual items rather than actually adding. So what do we do to get them to add, or get them to start adding?
Measurement model.
Right, the measurement model. Okay, if you're doing 5 plus 3 on the measurement model, you start at 5, you go up 3, 5 plus 3, you can see you get to 8. So you don't actually count the individual steps. You start at the 5 and then count up. Okay? So we're going to do some similar stuff with subtraction. Let me see, I believe we're in section 1.4 of elementary math for teachers. Okay. So here's what we're going to do. We'll talk about the models that we can use to introduce subtraction. This is something that wasn't on the agenda Friday. Interpretations. There are a couple of different ways to think about subtraction. There's really only one way to think about addition. We have this bunch of stuff, we have this bunch of stuff, and we're putting them together. Okay? That's really the only way to go. With subtraction, we have a few different interpretations, a few different ways we could think about it, and there are some different tricks with mental math. We've got to be a little bit more careful with subtraction. We could kind of just do whatever the heck we wanted with addition, move numbers around, but with subtraction, you want to be a little bit more careful. Okay, let me start here in the middle. The interpretations for subtraction. Okay, so let's start with the simplest one. Okay? Now some people even say it like this. Some people will say it with this. How would so 5 minus 3, but minus is a little more sophisticated. 5 subtract 3. How would like a second grader say that?
Take away.
Take away. Okay, they would say 5, take away 3. Okay, so there's something called the takeaway interpretation of subtraction. Okay, so this is best illustrated with the set model. Okay, so 1, 2, 3, 4, 5. 5 items. Take away 3, you're left with 2. Okay? Easy enough to illustrate on the set model. Now, as we start to do this, we're going to start to introduce word problems, okay? Actually, in the early grades, a lot of math is introduced as word problems. Heck, in the real world, a lot of math is given to you verbally. Okay, it's very rare that somebody says, here, do these 20 computations. Okay? We might be doing something like, when I have to do some reports later today, and I have some sections that I got to add together, right? So I'm going to be combining sections. I'm going to be doing this and that for figuring out how many students are in each class. Okay? So it's usually given to us verbally. Okay, so this is, of course, illustrating that 5 minus 3 is 2. So for each one of these interpretations, I want to make up a quick little word problem. Okay, I want to make up a quick little word problem that would lead a student to do this operation. Now, the takeaway interpretation word problems, well, pretty easy, just what you would think. Somebody has 5 of some item. Okay, of course, in the word problem, we're not going to say 5 of some item. We'll just make something up. Okay? Somebody has 5 toy cars. He gives away 3. How many does he have left? Okay, so so don't make these too hard when you're doing these word problems. Don't introduce extra people that we don't need. I guess you could say he gives away 3 to Carl, but now you've introduced another thing, and if I say how many does he have left, are you talking about Billy or Carl? Okay? So just be aware of that. Okay, so takeaway, really good to use the set model with the takeaway interpretation. Another interpretation of subtraction is the part-whole interpretation of subtraction. I'm going to start with a word problem here. Okay, so something like this. A class has 23 students. Fourteen are girls. How many boys are in the class? Okay? So, there are a couple of ways we could illustrate the computation here. The set model, I guess you could use the set model if you wanted to. You could make a blob like this with 23 circles. And then you could start marking off some that are girls. You could mark off 14 for the girls. And then the rest would be the boys. We could count those up. It starts to get a little tedious when you get into double-digit numbers to use the set interpretation, just because you have to draw so many items. Okay? So I might go with the number line interpretation for this. Okay, now there are a couple of ways to think about this. Okay, so 23 students in the class. All right, so we might start like this. so we're illustrating with the measurement model. Okay, so we got 23, and we got 14. So the question is, how far is that? So we're starting at 23, and we are going to count down until we reach 14. And the number that we count down, that's going to be our answer. Okay, so this is called the countdown interpretation. Okay, you could do a counting down. All right, I guess you could also go the other way. You could say, okay, we know we have 14 girls, 23 students total. We could count up alternatively. Okay. Start at 14 and count until you get to 23. Go the other way, okay? Either way, this distance is going to be found by doing 23 minus 14, and of course we get 9, right? So that would get us what we need. Okay, one more interpretation of subtraction, and that's the comparison interpretation of subtraction. Let's start with a word problem that would get us to think about the comparison interpretation of subtraction. Okay, well, something like this. Oh gosh, what do I want to say and or do? Let's say we have $17 cupcakes. We have 8 more cupcakes than cookies. Okay, so we're talking about comparison. You got to compare things, right? One quantity is more, the other quantity is less. Okay, so we have 18 more cupcakes than cookies. What kind of question would I ask after this setup? Remember, we're trying to get the students to do subtraction.
How many cookies do you
Right, how many cookies, right, of course. So, I think it's probably best if we use 2 bars here. Okay, so this first bar represents the cupcakes. I put a little CC right there for cupcakes. Here I just said cookies. Okay, so help me out here. Where would I put the numbers in this picture? I'm actually going to make a mistake on purpose, so don't write this down. Does that work? Is that the right interpretation? Well, no, right? I see people shaking their heads. One reason, of course, is because I told you I was going to make a mistake on purpose, so there must be something wrong. Okay, so what if I hadn't said that? How do we still know this can't be right? What is this showing right here? What would this indicate?
There are less.
Right, that we have 8 cookies, but we don't know that from the problem. They asked us to figure out how many cookies we had. So where should the 8 go? The 8 shouldn't go there. Say again.
Under the cupcakes?
Right, over here, okay? It should go with the cupcakes. It should be the amount of excess from this first ball, okay? It was the comparison interpretation. We have 8 more. So it's telling us how much longer this top bar is compared to this bottom. Okay, and then of course to get this length, well, it's a number such that whatever this number is plus 8 gets us to 17. Okay, so 8 plus question mark equals 17. And that tells us to figure out what should be in that question mark. We would do 17 minus 8. So that's what's called the missing addend. Okay, subtraction can be viewed through the lens of addition. Okay, as the students start to learn their addition facts, there are related subtraction facts. Okay, so 8 plus blank equals 17. Well, the student knows 8 plus 9 equals 17. That means 17 minus 8 equals 9. Okay, you know the one fact, you automatically know the other related fact. I guess before we go on, we should actually talk a little bit about teacher lingo. I said this word here, I said addend. From the context, what do you think an addend is? So going back to addition, and I guess another thing we should talk about, what's the fancy word for the answer when you get an addition problem?
Sum.
The sum, okay, so blank plus blank equals the sum. And these things are just called addends. Okay. They're both called the same name. Okay, because of course we can switch the order, right? Any order property of addition. We can move things around however we like. So it doesn't matter which one you put first. Now, of course, that's not the case with subtraction. You can't just switch them. Right? In fact, 17 minus 8, that's okay. For the primary grades, 8 minus 17 doesn't make any sense. Okay? So the order in subtraction matters. So they actually have different names. Okay, now, when you get the answer for a subtraction, that's called difference. Okay, that's the difference. Okay. You might not have heard of these before. This first thing is called the minuend. This second thing is called the subtrahend. Okay, they have two different names because we can't switch the order. The subtrahend is the thing you're subtracting. Okay, so we want to do 17 subtract 8. There's your subtrahend. 17 minus 8, minuend. Minuend minus subtrahend. Okay? So that's some of the lingo there. Okay, so we had 3 interpretations. Refresh my memory on what those were again.
Takeaway.
Okay, takeaway interpretation. What model do we use for the takeaway interpretation? Set model. Okay, we're typically thinking set model. How would you make up a word problem that prompted a student to use the takeaway interpretation? what would you do? Okay, right, so you have so many objects, you're either giving some away, or you're taking some away, or you're losing them, or they're broken, or he eats them if they're food, or, you know, whatever, okay? So, start with a certain amount of objects, and from some process, you lose, or they get taken away, or they get broken, or whatever. How many does he have left, okay? So that's the takeaway interpretation. What other ones? We had two more. Part, whole interpretation. Okay? So give me a word problem, not the one that we did, something else. What are the components that we need to do here? With the takeaway, we had a collection, and with some were being removed from the collection.
Have an item that's in different categories.
Okay, right, you gotta have two different categories. So in the example we did, we had a class and there were boys and girls in the class, okay? It could be basically anything that you want. That one's a pretty easy one, but we could say, okay, well, we have another class and so many are elementary ed majors and this many are early childhood majors. Okay, we have the two categories. Now, in the first one, it's easier because those two categories basically cover all the bases, right? But we might have to say in the problem that it's an education class or something like that. So you have two different categories, this many in one category, how many is in the other? So you have the whole class, the whole thing, and then a part. I guess that's really whole part, but that's the basic idea. Part, whole interpretation. What was the last one? Comparison. What would be the key word if you're making a comparison word problem?
More than or less.
Right, more than or less than or something like that. Probably more than, because we want to indicate this bar is longer and how much longer it is. Then they would do the subtraction over there. We could probably make it work with less than, but it might not actually be a subtraction problem, it might be an adding problem. Okay. So you got your interpretations and your models. Now this is another version of the measurement model. Okay, typically we'll deal with a number line. You could also deal with bars and the lengths of the various bars involved. Okay, when you're going to do a model of something, in particular when you're dealing with the measurement model, your diagram should include a question mark somewhere. Okay, you want to know what quantity to find. There should be something unknown. If there isn't, then we don't need to do a computation. Okay, so here, this length is the unknown. We want to find this length. Okay, well we know this length is 17. Take back 8, and that'll tell you that length. Okay? So your diagram should include a question mark somewhere to indicate what kind of computation we'll do. Okay, so at the top of the class, after we did the quiz course, I put 3 key ideas up there. What were they?
Models, interpretations, and mental math.
Okay, right. Models, interpretations, and mental math. Okay, so the models we talked about were the set model and the measurement model. And the interpretations were those 3. Takeaway, part, whole, comparison. Okay, so we need to talk about that mental math stuff. Now, I did mention that subtraction is a little trickier than addition. So we got to be on our toes here. Or whole, take away, done. Okay, so let me do some mental math stuff here. Okay, let's start with a warm-up. Okay, so 2 addition problems to get us warmed up here. Think back to what we were doing on Friday. Now, like I mentioned, as we progress through the course, these are problems we want to be able to answer without writing anything down. But for right now, let's indicate a step or two to show our thinking. Okay, so help me out with this one.
Move the 3 to the 7.
Okay, so we maybe write that down right there. So we're bringing 3 over. Now, why do we do that? Do we always bring 3 over?
To make a multiple of 10.
Right, the goal is to make a multiple of 10. Okay, remember, dealing with multiples of 10 is easy because we have a place value system base 10. Okay, so here you're turning a 2-digit addition problem, which would involve carrying, to a 1-digit addition problem. Okay? So we have, and I'll even write this down. Okay, 20 plus 60, which of course is 80, right? We don't need to do a 2-digit addition problem, we just need to know 2 plus 6 is 8. Okay? Now, down here, this one we could have done a couple different ways. You could have moved 7 over there and made it 30 plus 50. Either way, you get 80, okay? So a lot of flexibility. Now here, there's a best way to do this, and I won't say it's a wrong way, but it's a less good way. So what should I move and where should I move it?
Take 1 from the 2 and move it to the 9.
Okay, I could try that. So if I do that, I would have 491 plus 30, okay? Not bad, but it's still going to involve carrying, okay? So 9 plus 3 is 12, I have to carry the 2 over. So this is okay. There is a way to do it that's actually a little better still, so that there's no carry.
It's 8 from the 29.
Okay, right. Now the reason that's better is now it's actually I guess it's almost a no-digit addition problem. So I move 8 that way. This is 500 plus 21, 521. Okay, no carrying at all. So when you're doing the mental math addition, try for the maximum number of zeros. If something's close to a multiple of 10, then compensate. Okay, that's what this process is called, compensation. Compensate to make it an even multiple of 10. If something's close to a multiple of 100, that's even better. That has more zeros. And zeros are great because they make the addition problems easier. Okay. Now when we're doing subtraction, we got to be a little bit careful. Okay, now let me try something like this. Let me try that. 54 minus 19. Okay. Now, the temptation might be, the temptation might be to take 1 away from the 54 and put it to the 19, okay? Just like what we were doing before, okay? Got to be a little bit careful here, though. If I did that, if I did 54 minus 19, and I brought a 1 over here to do 53 minus 20, well, that would give me 33. Now, of course, we can always check our work with a subtraction problem, right? What we can do is add this number to see if we get back here, okay? If I do 33 plus 19, do I get back to 54? No, I get to 52. 33 plus 19 is 52, not 54. Okay, so we want to make sure we indicate that is not the way to do this problem. Okay, the reason it's wrong is because we're supposed to be at 54 things, take away 19. If we do that, if we do this step, now we're starting at 53, which is less, and we're taking away even more. Okay, so we end up with something too small. Okay, so that's no good. This is the way I usually think about it. Okay? Taking away 19 is tough. It'd be easier to take away 20. Why is it easier to take away 20 than 19?
It's a multiple of 10.
Multiple of 10, so it's a one-digit problem. Okay? That one's an easy one. What's the answer to this?
34.
34. Okay? Now you took away 20, you weren't supposed to. You were supposed to take away 19. Take away 20, throw one back. Okay? So here's our correct answer, 35. Okay, so when you're doing compensation for addition, it's this second thing that you want to concentrate on. You want to subtract a multiple of 10. Don't worry about this. Okay, don't make that a multiple of 10. In some cases, that can actually make the problem more complicated. Okay? So, let me try this one. Okay, 78 take away 49. Try it in your seats. Do a compensation to make that an easier problem. Okay, looks right. Remember, it's the thing you're subtracting that you want to make a multiple of 10. I know the first thing, the minuend is close to a multiple of 10, so there might be a temptation to make that an even 80. But 80 take away something that has a second digit, now you got to do borrowing anyway, so that won't help. Yeah, that should work. Okay. Okay. Okay, so instead of taking away 49, what are we going to take away?
50.
Take away 50. So we're going to do 78, take away 50. That's of course too much, so we're going to throw one back. Take away 50, then throw one back. 78 take away 50 is 28, plus the 1, 29. Okay? So be careful with that when you're doing mental math and subtraction, okay? And because in subtraction, order matters. With addition, any order property, we can basically do whatever we like, okay? So keep that in mind. So, read through Chapter 1, Section 4 in Elementary Math for Teachers. So that is pages 19 to 23. Okay. For homework, I want you to look on page 24. Do problems 1 through 6. Okay, don't worry about 7 or 8, just 1 through 6. Okay, remember those, along with the addition problems, that's what I'm going to quiz you over on Friday. I guess you folks in Zoom land, I'm going to quiz you on Friday. Okay? Now we're also going to have a quiz on Monday. Okay, so I'll figure something out as far as the quiz is and how both groups are going to take them. Okay, so I'll see you guys on Friday.